All right, guys, today we're going to be doing lesson 2-1, where we're going to be graphing two variable equations. So make sure you have your Springboard book handy, something to write with, and a calculator, because we are going to be doing some calculations here. So we are on page 17, and we're going to be doing our targets today are writing equations in two variables to represent relationships between quantities. And then the big thing today is we're graphing those on a coordinate axis with labels and scales. So read along with me this scenario that we have here about Roy. Roy recently won a trivia contest. The prize was a 5-day trip to New York City, including round-trip airplane tickets and $3,000 in cash. The money will pay for a hotel room, meals, entertainment, and incidentals. So to prepare for his trip, he gathered this following information. Okay, he knows the hotel room is going to cost $310 per night, and he's going to be staying for 5 nights. A taxi between New York City and the airport is going to cost $45 each way. So Roy has to set aside the cash to pay for his hotel and for his taxi service to and from the airport. Once he's done, he can begin to make plans to do with the remaining funds. So all the fun stuff he wants to do, he has to see how much money he has left over. So take a second really quick, figure out how much money Roy will have available to spend on performances, meals, and any other expenses that may arrive after paying his hotel and taxi fees. Okay, well, if we calculate this really quick, we should have, if Roy is going to be spending $310 a night for 5 nighs, okay, then that should give us, let's calculate that really quick. That should be $1,550. Okay, he also has to take his taxi ride, that's $45 each way. Okay, so that's going to be costing him $90. Okay, so if we think about this, Roy had $3,000 to spend. If we take away the cost of his hotel and his taxis, he should have that he has $1,360 left over. Okay, so he's going to use that money to go to all his fun things, performances and meals. Okay, all right. During his trip to New York City, Roy wants to spend only his winnings from the contest. He wants to focus on 2 of his favorite things, attending theater or musical performances and dining in restaurants. After surfing the web, Roy determines the following facts. So Roy knows on average a ticket for a performance costs around $100, and he kind of calculates that he's going to be spending $40 on every meal. Okay, so keep that information handy when we go to the next page here. All right, so right now we're just going to focus our attention on the tickets for Roy to go to the show. So remember, he said it's probably $100 per show or per ticket. So we'll use that information coming up here. So Roy wants to know how the purchase of each ticket affects his available money. So from the last slide, we figured out that he's going to have $1,360 left over, okay, for going to shows and dining, okay? So we're going to just focus on the tickets, like I just said, but I want you guys to fill in this chart here. It wants to know how many tickets he spends, how that affects what money he has available. So again, if he doesn't go to any shows at all, he's going to have that $1,360. So I want you to fill in the rest of this chart. If he goes to 1 show, how much money is available then? 2 shows, 3 shows, and so on. Just be really careful in this part right here because it jumps from 5 shows to 8 shows. So go ahead and fill that in. Take a minute and pause the video. Okay. If you filled in the table, it should look something like this. So every show he goes to, that's going to deduct $100 from his bottom line here, his $1,360. Okay, so now I want to represent this in a graph. So this graph right here, I'm going to have you guys plot those points. So you have the number of tickets along your x-axis, money available along your y-axis. So go ahead and plot those points for me really quick. Okay, if you did it correctly, your graph should look something like this. So what patterns do we notice that are going on here? Well, hopefully you said something about maybe the graph is decreasing. Okay, we could also say that this is forming a linear pattern. Okay, so we have those kind of things pointed out. If you come up with anything else, that's good. But so how did we determine the value for 8, 10, or 13 tickets? Okay, you guys filled in this chart, so I'm sure you know how to answer that question. So I'm going to skip to the next one, where we actually write a function, m of t. So this function m of t is going to represent the amount of money that Ray has after he bought t tickets. So think about how you found it for 8 tickets, okay, 10 tickets or 13 tickets, like how you filled in this chart, but take out this number and replace it with t for tickets. Take a second and think about that. Okay. So hopefully you took that we have $1,360, and we're going to subtract $100 for each ticket for each show that we go to. So that would be our function, okay? And a function is a relationship between two quantities. So in this case, we're talking about the amount of money he has left over, relating that to the number of tickets for the shows that he goes to, okay? So taking this equation, we're going to kind of copy it over here so we can talk about it a little more. What would we say that negative 100 represents in our problem? Okay. Now this is written a little out of order. We're used to seeing the x go first, right? So this is technically in slope-intercept form. It's just moved around a little bit. So that negative 100, that's representing our slope here. So that's the amount of money we're spending every time we buy a ticket. So that's what's changing in our graph. What is that 1360? Well, that's the money we started with, right? So that represents our y-intercept. Okay. All right, so we're going to do the exact same thing now here, but we're just going to do it with his meals. So a little note to kind of point out that Roy estimated it's going to cost him $40 per meal every time he goes out. So forget that we went to any shows or bought any tickets at this point. So we're just focusing only on meals. We're going to write a function, d of m, that represents the amount of money Roy would have left over after purchasing m amount of meals. So go ahead and think about what that function would look like. Well, hopefully it's very similar to our first equation, except for 100t, we're doing $40 per meal. Okay, so that's what our function looks like there. So what we're going to do next, we're almost done here, is we are going to take this function now and graph it. Now there's a few ways you can graph it, okay? Figure out what works best for you and go ahead and graph this function on the grid below. Okay, hopefully your graph looked something like this, okay? And you can also use a graphing calculator. You would have to change your window quite a bit, but the book did kind of give you a window that you could work with there. Okay, or you can use that Desmos application I talked to you guys about. But what kind of function is this d of m then? Well, this function is also looking pretty linear, right? And what was our rate of change? How is our graph changing every time? Okay, well, it's decreasing by $40, right? So that's why we have a negative slope here. because every time Roy goes out and buys food, he's taking away from his bottom line of his prize winning money. Okay, so just remember in the future, the rate of change of a function is the ratio of the amount of the dependent variable and the independent variables, how they're affected. So we're talking about the slope here. Anytime they're talking about rate of change, we're talking about the slope. Okay. And let's think about this. We had a question like this similarly in notes before, but are all values of m on your graph valid for this situation? So what that means is, can I plug in any value for m and it makes sense for this situation? So remember what m stands for. Can we have any number of meals? Okay. Well, hopefully your answer is no, okay? And that reason being we can't buy anything negative for meals. So m can't be a negative number because we can't go out and buy negative meals and spend negative amount of money. That doesn't make sense, okay? And also, if we look at our graph here, what's eventually going to happen to Ron's meals, or Ron's money, I guess, okay, is eventually he's going to run out of money, right? He doesn't have unlimited funds. So he can't have like 100 meals for say. He doesn't have enough money for that. Okay, so we can't have negative meals. Those values wouldn't make sense for m, and we can't have numbers that are too big for m either, because then you're kind of going into the negative. And remember, Roy only wants to spend his winnings from his contest. He doesn't want to spend any of his own money. Okay. So today's lesson was mostly just focusing on being able to write an equation from a scenario and represent it graphically, okay, on a coordinate plane using the right axes and scales. Okay, so that's the end of 2.1. So I'll see you tomorrow for 2.2.